Just draw a 90-degree triangle and go from there. 90 degrees. Now you can work with it. Okay? Some of you won't need to draw the triangle. Some of you will get it. It's okay. I understand that. Ike, standing on a soccer field, looks at the roof of the school with an angle of elevation of 30. Okay. So the roof must be off the ground, right? Where do angles of elevation live?
At the bottom. At
the bottom, looking up. Well, there's no angle inside this triangle up here that's looking up, so it has to be down here. There's our 30. Ike is 42 meters away from the base. Where's the base of the school? It has to be the 90 degree, so that's 42. How tall is the school? Do I care about the hypotenuse or the wall of the school now?
The wall.
The wall of the school. So that gets my variable. I'm going to use W for wall. Okay, that's it. All trig questions are that easy. Draw a triangle. Write down what you know. Write down what you need to know. Choose your ratio and solve it. That's it. Now, the only difference between today and what we've been doing in the past is what we were doing in the past isn't real life, is it? It's a drawing of a triangle on a piece of paper. But you're going to take that and apply it to a real life situation. Now, here's where you can get dodgy. How tall is the school? Technically, is Ike lying on the ground? No. So technically, Ike's eye would be right there, wouldn't it? And you would have to add some height to the school. Do you think I care? No. Sometimes I'll specify, right? Because remember, I like to let you guys know about real life, right? The real life guys that do this, those guys looking through the telescope at the other guy in the high-vis vest, he looks at the other guy and the other guy goes like this, and then they do a bunch of trig and they all get paid a buttload of money to do it. Those guys have to care about crap like this. In math, we don't. Math 10, we don't care. Okay? When you get to physics, they care about stuff like this. Right? Or applied math, like engineering. But here, I need you guys to get the concepts down. Right? So we're not going to get persnickety about this extra 1.5 meters here. Right? Everybody cool? Okay. So, of course, you have a theta. It's 30. You have an adjacent, which is 42, and you need an opposite, which is W. So what do you use? Tan. Tan 30 equals opposite W over adjacent, 42. Numbers on the bottom, so is it times or divide? Times. 42 tan 30. Know what your calculator does. Somebody work that out for me because I've given all my calculators away. What is it? 24? 24.2. Let's go to one decimal place for distances today. Everybody cool? That's it. Now here's where trig gets difficult. Can the triangle be in any orientation in our entire universe? Yes. So you can use the triangles to measure straight up and down. You can use the triangles to measure sideways. You can use the triangles to measure diagonally. The triangles can rotate anywhere. But they are still a 90-degree triangle. Okay? Everybody good? The problem is drawing it becomes difficult because the world is in 3 dimensions and our paper is only in 2. Right? Okay. So here is the next question when it does get difficult. Abby is flying in an airplane at 2,500 feet. So here's my airplane. I'm super good at Pictionary. I'm the pilot. And since we're that close, we're about to land.
You need another wing.
It's a big jet. I'm super good at Pictionary. Wait, the back landing gear usually has a few more wheels. Everyone says that's a bad drawing, but everybody knows it's a plane, so. I win at Pictionary, therefore I am a good drawer. Ah! Oh no! Wait. Okay, shut up. It's time to do math. There I am. Okay, so there's my plane. Again, the plane is where? Good job. He looked up. Yes, the plane is up in the air. Now, in reality, there are how many dimensions? 3. But I can only show 2 on this piece of paper, yeah? So the plane is up in the air, some amount of space. How far up in the air is it? 2,500 feet. Right? How far away horizontally is the town of Mission? So where is horizontally? It's flat, yeah? Now, where can I put that horizon line, the horizontal line right now? Can I put it on the ground? Is that horizontal? Sure I can. Can I put it up here? Is that horizontal? Both will work, yes? How far is this distance? 2,500. Now, what else do I know? There's an angle of depression of 15. So, where is an angle of depression? Going up, it's going down from above, yeah? So, I'm looking down at the town, right? Now, where is that angle of depression? Is it yellow or bleu?
Yellow.
It's where you start looking down to where your eyes end up. So I am up in the plane looking this way, so I look down. Here is where the 15 is. Now the problem with this is all of you wanted to put it here, which you cannot do. However, you should be aware that if this is 15, what's this? 15. So you can do this bottom triangle as well. They are the same. Now, do I have a theta? 15. Do I have an opposite? 2,500. Do I have an adjacent? No. That's my horizontal distance, right? There's my x. What uses O and A? Tan of 15 equals O, 2,500 over A, x. Variable on the bottom, so it's divide. 2,500 divided by tan 15 equals x. And I don't have my calculator, so you guys are going to do it. Are you picking this up? Just draw a triangle. No matter what, it's very difficult to do trig without a triangle. Now let's review our vocab. Angle of elevation goes from where to where? The horizontal and then up. Angle of elevation. Look at somebody, something, Danielle, then move your eyes up. The angle of elevation is where your eyes move. Angle of depression, look at something, Nikisha, move your eyes down to here. The angle of depression is in between where I started and down. Okay. Is everybody good? That's the only vocabulary that you need. Number 11 is answered wrong every time I get my classes to do it. Because I always do the first two, and I say, okay, everybody's got it, right? And they say, wrong! Do number 11. Do it on the left, because chances are someone's going to screw it up. If you've already done number 11, that's cool. Then just wait and see if, rest on your laurels and see if you've done it right. You can talk. You don't have to, this isn't a test. You can chit-chat with your neighbor and see if you sorted it out properly.
19, yeah. No, would this be the 19?
I feel like it goes like this. 19.
19 is the bottom. Because it goes 19 this way. Yeah. Then it rises 1 meter. So would that be the...
I think it goes like this.
Why are you doing your pen?
She's badass.
I don't have white out.
That's real. That's like jumping without a parachute. Undo my math and pen. I got Snow White out. Yeah, boy. I put too much sugar in this tea.
I've done that.
Oh, that was there before.
I just like to keep one.
I put milk. It depends what type of tea I have.
I usually only put milk
Do
in
you think like chai tea?
Earl Grey.
Yeah. Okay.
Usually I would put it in English breakfast, but I don't have any.
I don't know. Tea I like is
I drink a lot.
I like the peppermint tea. Actually, I like there's a mint tea that's peppermint and spearmint mixed. I really like that.
I put honey in my tea.
I usually put honey in my tea. You know what I found? Crystal honey. Honey that's like sugar. So it's not messy.
It depends the tea.
It's
My
pretty
mom
wicked.
buys vanilla sweetener from Starbucks.
Huh? Honey doesn't what?
Honey doesn't have an expiry date.
No, honey is the only food that doesn't go bad.
Yeah.
So does it dry?
I don't know how they make it. What do you want from me? I just eat it.
The bees don't make crystals.
I don't know.
Okay.
This is a one.
So what did I say you need to do to start a trig question?
Dry.
How many people drew a triangle? Excellent. So your triangle would look like this, yeah? It rises 1 for every 19 measured along the road. Where is the road?
Is this way? Because it goes up, right?
This is the road. You cannot drive up a mountain by driving into the middle of the mountain and then driving straight up. Okay, I need, right? Like it's not the way it works. That's not the that train that goes through the Rockies doesn't plow into the mountain and turn 90 degrees and go straight to the top. It doesn't work that way. See what I'm saying? That's the trouble. It's not the math that's difficult, right? It's the concepts and the reading of the questions that is difficult. Because the math is always one operation, isn't it? Divide or multiply by a tan, a sine, or a cos. So, now, excuse me, now we're sorted out, yeah? But the question says, how far does a car travel horizontally when it goes 300 meters along the road? So this is a real life question. The question is asking, where in the world is the car located? Because the car isn't driving through the mountain. But if we were to have the car on a grid system, it has moved both horizontally and vertically, hasn't it? And that's where the reality, the application of this type of math comes into play. So, what I need is this triangle. I have now gone how far along the road? 300. Yes? I need to know this distance, don't I? Right? Now, what do we know about this ratio? What is the ratio that we have for there? What do I have there?
Opposite and hypotenuse.
I have an opposite and hypotenuse. So can I find this angle?
Yeah.
How?
Using
Sine theta equals opposite 1 over 19, correct? But I don't want the decimal, do I? What do I want? The angle. So I got to do shift sine and find out what it is. So once I have that angle, what is it?
Three.
3 degrees. So now do I know this angle? What is it?
3.
3 degrees. Now, do I have a theta in the big triangle? What is it?
3.
3. I have an h of 300. I need this. What is that?
Adjacent.
Adjacent. So what am I going to use now? I heard someone say cos. Cos of 3 equals adjacent x over hypotenuse, 300. And what math do I do?
Multiply.
Multiply. Now, there's another way to do this question. Did anybody do a different way? There's a way you learned in grade 9 to do this question before you ever did trig. Kelsey, what'd you do? Yeah, you can do similar triangles, can't you? 300 divided by 19. But then you would still need this side, right? You would have had to Pythagoras the top. Yeah. Yeah, you Pythagoras the bigger one. Yeah, they both work. Okay, everybody cool? Once again, the reason I say this is because there's more than one way to do the question. All right? And Kelsey may have chosen a completely different way than me, but this is not elementary school. I will not dock you marks if you find another way to do a question and get the answer right. The only time I would dock you marks is if all of the work you've done gets you to a completely different number, and then all of a sudden you write the right answer over here and circle it with no work. That I might dock you for, because there's no way your work got you to that answer. You understand? That says to me, you looked over. Right? I will never accuse you of looking over. I will simply say, hey, do this question. Nice, quietly, and privately. And if you can't do it, then I'll know you cheated and we'll have to talk. Okay? Okay. Oh, what was the answer, by the way? 200? 299? Okay. Now we are starting to get into... Notice I have changed from a real-life situation back to a math class, yes? This isn't a yard. This isn't a parking lot. This is a rectangle on a piece of paper, right? So why am I doing that? Because we're going to go a step further with our trig. We're going to use one triangle to solve a second triangle, which is what we just did in two ways. Kelsey did it with Pythagoras. I did it with trig. We're going to do that here. Then we're going to use it to solve real-life problems, okay? So we'll start with this one. I need the area of this triangle, or rectangle. So to find a rectangle, I need what? What do I need to find the area of a rectangle? Length and width. There's my L, there's my W, correct? So if I can find L and W, I can find the area, right? Okay, so let's do that. Do I have a theta?
21.
21. What else do I have? An hypotenuse of 12.7. And I have an opposite of what? W. And an adjacent of what? L. So now I can just solve it, can't I? Because I've got all the information I need. O and H uses what? Sine. So sine of 21 is O, W, over 12.7. 12.7 sine 21 will get me W. Cos 21 is L over 12.7. So 12.7 cos 20 will get me L. Now, why haven't I gone to my calculator yet? Does anybody want to guess why I personally have not gone to my calculator yet? A little bit of tea came up the back of my throat, almost came out my nose. Christina is right. Physically, I cannot go to my calculator because I do not have one in front of me. But in reality, why have I not gone to my calculator? Do I need these numbers yet? No. How many times have you punched the wrong button on your calculator in your life? Many, many, many times, yes? So I'm avoiding my calculator because I know area equals LW, right? So doesn't area also equal 12 sine 21 times, or not 12, 12.7, sorry, times 12.7 cos 20? 21. Now, if I go to my calculator here, I don't have to remember anything. I don't have to write anything down. I don't have to round anything off. I don't have to punch in 6 things here, 6 things here, and then multiply 2 numbers. I can do it all in one shot. Do you see what I'm saying? Do you have to do it that way? No, of course you don't. But it allows for efficiency. Okay? So again, you can punch it in however you want, but I would punch it in this way. I do as much work on paper and in my head as I can for 3 reasons. 1, I don't trust my fat sausagey fingers because I make mistakes. 2, I don't trust the calculator because it can only do what I tell it to do. If I hit a wrong button, not necessarily a wrong number, a wrong button, then it's going to tell me the wrong thing. And 3, I do trust myself to write out work because it also keeps me organized. You guys have all seen pictures of university classrooms where the boards are filled with equations, yes? It's like that for a reason. You can't do high-level math, physics, chemistry, anything with numbers and try to do it without writing it down. You can't. It doesn't work. We have done you guys a disservice by slowing your math education down so much that one problem is all you need to do here in your 11th year of math education. Right? Many of you play sports. If you were still 11 years after starting learning how to dribble the ball through the cones, would you be much of a soccer player? No. Right? If you were still learning 11 years after picking up the basketball for the first time how to do a bounce pass to your teammate, are you going to be a good basketball player? No. But for some strange reason, we think it's okay to give you a millimeter of math at a time and then expect you, when you leave here in grade 12, to go to a university classroom where the walls are one equation. Do you see the problem? That's why I like to write stuff out without going to my calculator. Everybody cool? All right, try the next one. Oh, I never even did the answer. What was the answer?
53.96.
53.96 sounds awesome. Whatever it was, centimeters squared. Meters squared, lovely. Okay, so again, artificial situation, that we will use to solve a real life situation. I need MN. Where is MN on this drawing? Right here, yes? So that's the side I need. So I'm going to go ahead and give it a name. I'm going to name it small l because he's across from big L. Is that cool? All right. How many pieces of information do I need in any triangle to know everything in the triangle? How much? 2. What 2 pieces of information do I need? You need, for any triangle, what do I need? One side and an angle. Or 2 what? 2 sides, because 2 sides can allow you to shift sign to get an angle. Right? Is 2 angles of any use to you? No. So you need a side and an angle or 2 sides. So if I'm going to get L, I'm going to need another side, aren't I? Where can I find that? Where is the side of L that I can work with? It's right here, yeah? Because that side works with this angle and that side. Understand? So, what am I going to do to find side M? And I'm stressing this. I want you guys to start trying not to go to your calculator until you actually need to. So in this triangle, which I'm going to highlight in blue, what do I know? Do I have a theta?
33.
Theta is 33. And what else do I have?
Hypotenuse.
I have an hypotenuse of 8.2. And I have an adjacent that is M. What uses A and H? Cos. Cos 33 equals adjacent M over 8.2. So what does M equal? 8.2 cos 33. Everyone agree? Can I go to my calculator now if I wish? I can. It's going to give me a big long decimal, and I'm going to have to write down part of that decimal, yes? Will it be exact what I write down? No, because I'm going to be rounding it, aren't I? Which, okay or not okay in math class? What do you think? Is it okay or isn't it? You guys know me. Do I care about concept or answer? I care about concept. So is it okay that you're going to do this now on your calculator and give me a rounded answer? Does this show me you know how to do trig? Yeah. I'm sending a rocket to Mars. Can I round stuff off? Why? Because it needs to be accurate. If I'm a millimeter off between me and Case, and I'm going 10 million kilometers, how far is that millimeter off going to be by the time I get where I'm going? Understand what I'm saying? People are always talking about real-life math. When are you going to use this in real life? I can't tell you when you're going to use it in real life, but I can tell you when you're going to use the habits in real life. So that's why I'm not going to my calculator yet. But you can, right? So now, in yellow, do I have a theta in the second triangle?
49.
49. What do I have? I have a hypotenuse of my second triangle, don't I? What is it? No, the hypotenuse is M, which I know to be 8.2 cos 33, yes? And I have an opposite, which is little l. What uses O and H? Sine. Sine of 49 is O, L, over 8.2 cos 33. 3. What do I do with that? Multiply 8.2 times cos 33 times sine 49 to get L. There's a reason I want this type of construction in your brain, because we are going to be doing math later on where this type of math will be helpful. Do I insist that you use it right now? Of course not. Go ahead and find out what M is, find out what L is, do it the way you want. But be aware that this is another option. Do you understand what I am saying? Now, what you should get, of course, is 8.2. 8.2 times. I don't need to push times on mine. That was stupid. 8.2 cos 30. Was it cos 33? Yeah, cos 33. And then sine 49. 5.19. So 5.2. Is everybody okay? Could you have done it the long way? Yes, you can. I just need you to be aware that sometimes you're going to want to keep stuff like this. Okay? Just like when we were doing surface area and we left pi, right? Instead of going to the number. Okay? It's just like that. Now, I'm going to shut up because I can see eyes are glazing over. I understand that, and that's fine. I want you guys to go for in class today. You probably won't get them all done. I hope you will. Do up to number 20. The two boys looking at the mountain. Okay? Tomorrow in class, we're going to do these word problems. You're welcome to look at them tonight if you want, but you don't need to. Okay? Because I want to work on these in class tomorrow. Now listen to me, please. You will have noticed I gave no quizzes for this, have I? Because let's be honest, it's one operation, isn't it? Right? I've given you no quizzes up here, but I've given you buckets of practice that is completely pressure-free. Yes? Because you always have the answers, or I'm not marking it. Okay? Everybody good? So what I would like to do is sometime before the end of the week, I would like to give you a very short quiz on all of SOHCAHTOA. So right angle triangles, I'm talking like 5 questions, if that. Okay? But they will be of the word problem variety. Okay? Maybe even only 3. Everybody cool? And I won't even do it until Friday. Oh, wait. Friday is... You guys are what block? D? So the bio game doesn't affect you guys, right? Okay. So Friday, I'm going to... Yes, Luke. Well, you will... I know. Because you're playing football. Right? Okay. Great. So what are you going to have to do? Watch the video and do the work. Okay? Your quiz will be Friday. And it will not be big, which is bad C. Day 2 is bad C. The buyout goes at 1 o'clock. It only affects block C. It doesn't affect you guys. So it's the same today. That's what I've been saying. Okay. So go. Start working. I'll shut up.